Hello, ladies and gentlemen. We are continuing with Chapter 18. We have talked about covalent bonding, we have talked about ionic bonding, and today we're going to talk about metallic bonding. But before you panic, don't worry, there are no drawings because it is near to impossible to draw something that is being metallically bonded. Okay. When you're talking about metallic bonding, you are not just talking about a bond between two atoms. You are talking about metal as a whole. Okay, the image that you see, the gray circles would be the inner part of an atom. So you have the protons and neutrons and the inner levels of electrons that are filled. Now, metals have essentially almost no electronegativity. So what happens is the electrons of a particular metal atom don't stay, and they're not taken away either. It's just kind of the atoms float around between all of the electrons float around between all of the different metal atoms. And it gives this strange appearance that the electrons are just kind of traveling wherever. This is referred to as the Electron Sea Model. So it's kind of like you have this structure of metal atoms, but the electrons are just kind of wherever. It doesn't really matter because the atoms aren't holding on to the electrons very well at all. Now, the reality is that because the electrons do this, the metals are able to have some really different types of properties than a lot of different substances would be able to have. Because if you try to move those atoms around, they're still covered by electrons. They're still connected. So you get these really cool properties that are pretty much only of metals, at least for metal to be able to have all of these things. First off is the property of being malleable. Okay, you see the mal in there, like mallet. That is the idea of a hammer. Now you can see you have this thing coming down onto the metal. But you notice when the atoms get pushed away, they still have electrons around them. Okay? It does not matter what shape this metal right here is in, because no matter what, it still has other atoms and other electrons that are holding it all together. So that's why you can do this to a metal. You can hammer it, you can change its shape. You can see the different objects here that are created using this property of malleability. The nature of the metal just allows you to be able to push the atoms around and to be able to create it. Now obviously if it gets too thin, at that point it would break because you wouldn't have enough electrons, and that's when you start getting a hole in your metal. But primarily you can hammer it and be able to create these different shapes with it. Okay, second, we have the fact that metal is ductile. It can be pulled into a wire. And you can see right here, as the metal comes through into this machine, it actually simply changes shape as it's being pulled. Now, this machine right here is actually used to test how ductile a particular metal is, because they want to make sure for industries that it has a certain amount of ductility. You can see it's literally like it's stretching it like it's a rubber band. But what they're doing is they are pulling this metal and having it come into this shape of a wire. Now, again, this can happen because you're able to move the atoms of the metals around. as long as there is enough metal there that there's electrons between them, you can keep pulling and pulling and getting as narrow, thin wires. Now, if you get too thin, that's when the metal will snap and break. And different metals have different ductilities. But this allows you to see some of that properties. Okay, the one on the left is an animation, but the one on the right where they're testing it, that is an actual test being performed. They're stretching the metal out. And that is ductility. It is ductile. Okay, next you have the ability of metals to conduct electricity. Now, electricity, if you'll remember, is just moving electrons. So what happens is, since the electrons of the metal are literally just kind of floating wherever, if you add in electricity from one side, it's just going to take their place and shove them out the other side if there's too many. And this is what we call an electric current. Okay, the electricity going in one side being shoved out the other side. An electric current. That is how a metal is actually able to have electricity go through it. It's just bumping those electrons along from one atom to the next until they get bumped off. Okay, and we usually think of conduction for electricity, but metals also have conduction for heat. And you can see when you add the heat, the atoms are able to just move around and get hot, and they can pass that on, because what you're doing is you're increasing the speed of the electrons with the heat. And the electrons here will pass it down and pass it down and pass it down, and eventually, if you were the person holding this piece of metal over the flame, it would be very hot. Okay, so the heat gets passed down because electrons can move too. Okay, now not everything that has luster is a metal. Things like glass have a luster. Luster being that shininess to it, so it reflects light. But what is unique about metals is they have this unique luster. So when you look at a substance that is metal, you know it, unless it's oxidized. You see that shine to it. Okay?